Okay, is this one on? Is this one on? Okay, great. So this is the Information-Centric Networking Research Group, Icnrg. Welcome. It's co-chaired by me, Börje Uman, and Dirk Kutcher and Dave Oran. Okay, let's see if we get this working. We have the note well that I think most of you have seen. There is a slight difference between the IRTF and the IETF that we require a bit more timely disclosure of IPR things. So if you haven't looked at that, do that. I know that there has been an update to the IETF. It's still unclear to us if this one should be updated in accordance with that or not, but we used the one we used for the last couple of times still. We don't have Alison in the room, do we? No. Okay. So, yeah, this is the basic infrastructure for our research group. We have the mailing list, web, wiki. The wiki is the place where we keep agendas and meeting announcements and so on. So if you want to keep updated, that besides the mailing list are the two main resources. There is also a GitHub. And for the meeting now, we have an Etherpad where we will take notes, and anybody is welcome to help out adding to the notes. Do we have anybody that can volunteer as a note taker for this meeting? Cedric, are you fine with doing it? Yeah, great, thanks. Sorry? Do we have
someone for the second half?
It's just 2.5 hours.
Hopefully we don't break it up.
Yeah, yeah, okay, great. Thanks a lot. Cedric did it many times, but he's a good resource. Thanks. And the meeting materials will be available at the data tracker.
I just uploaded share slides.
The share slides are there as well as most. They just got there now, Steve says. Okay. Then I think we should start the blue sheets. Can you hand them out? And then the next thing is we had a Sunday interim meeting, and I leave for Dirk to talk us through that.
Okay.
Can you? Well, right. Actually, we should do the agenda first for today. So this is the agenda, first half of it, and the second half of it. Anything we missed or any comments to the agenda? We reshuffled the last presentations a little bit, mainly for Ravi. That makes a difference, and for Schenk. Okay, so I think the agenda. By the way, I should also mention that the minutes of the Sunday meeting is uploaded as said, and it was sent out on the mailing list for comments, and we haven't heard anything on that. So unless we get some comments by the end of this meeting, we will consider them final and upload them. Okay.
All right, thanks. So we had a full day meeting again on Sunday, which was actually quite interesting if you haven't been there. So not sure if you heard that. There was a previous ICN fog computing workshop at IFIP Networking. So we have a kind of report on that if you're interested. There are a couple of papers and presentations that are really relevant to the work we are doing here. We earlier mentioned the Intel and NSF sponsored research program for ICN wireless edge computing. So we got an update about the selected projects and so what they are doing. And then we had a couple of ICN research presentations. So one by Edmund on using NDN for data-intensive science. So think about disseminating CERN LHC data dissemination. So one by Lisha, so on ICN augmented reality in wireless edge. So how you would leverage ICN features for that. Cedric on network coding, ICN, and Yannis about a mobile application sharing framework based on ICN. And then we had a slot with some demos. So first, Luca updated us on the FIDO CICN project. So FIDO is a Linux Foundation open source project for like a software switch architecture based on VPP. And so there's a ICN activity in that project that develops an ICN stack that is leveraging this underlying framework. And so we also got to get a demo of how you could build, for example, emulated networks using the ICN software and configure them and do things like multi-access communication and so on. So that was pretty interesting. Next slide, please. And we also kind of discussed a little bit of some of our, say, research or work items in the group. So an update about the harmonization work that is continuing. Had a bit of a discussion on a new activity that we call ICN principles. So it's basically describing a set of core properties or like invariants for some ICN architectures. Jungha gave us an update about a research project in Icnrg. It's called hyperconnected IoE network technology. It's basically using several ICN technologies, so ICN networking, name resolution, and so on, to build a, say, larger system for data dissemination, for example, also IoT. And then Bastian updated us on the terminology document that we have. So it's like clarifying some of the key technology for ICN that was recently updated. You may want to have a look. Ravi presented a draft discussing like enabling network identifiers, ICN, and Jungha gave us the update on the name resolution document that she and others are working on. And so finally, we had a, say, new contribution from colleagues in China who are trying to figure out how ICN could say support a little bit of say service awareness. So I think largely for content distribution networks. So there was a draft, and yeah, that was the program on Sunday. So they've already sent around the minutes, and the material is all online.
The minutes are still available on the Etherpad. They'll be uploaded as final version after this.
Yes. Okay, moving on. So before this meeting, we issued last calls on 2 CCNX specification drafts, so messages and semantics, and kind of specifying like the base CCNX protocol essentially. And so from our perspective, we got positive feedback and say no issues were raised to us. So we would consider this last call as complete, finished. And that would mean we could actually move these documents forward.
So I think Allison's over there. So those two documents will be going to you for IRTF last call and IRSG review.
Yeah.
I'll get the Shepherd thing get to you by the end of the week. Thank you.
For a while, the IRTF was all disappeared, but now I should be able to check it.
All right, so expect that by the end of the week. Those are, by the way, for everyone, those are intended as experimental RFCs because they contain protocol specifications. They're not, they're pretty core documents that many people are using in order to actually build real systems. So they have a reasonably high degree of importance to this community. Thank you.
Yeah. And okay. So we think that's actually a good milestone that we reached, that we finally publish say specification documents coming out of this group. That's something we actually want to do more in the future. So if there's something you are working on that would be of this nature, we'll be really happy to help progressing that. And with that, let's.
Yeah, just on that, we have a number of other protocol in the pipe that's been around, and please have a look at them because they're going to come up for last call fairly soon. Some of them also.
Okay, is Prakash in the room? Yeah, okay. So let's start with our first presentation then. Get a clicker.
Yeah. I should do this first.
Morning, can everyone hear me? Okay, so good morning everyone again. My name is Prakash Sutar. I work for Cisco and I have two of my other colleagues on the call as well, but I'll be presenting on their behalf. What I'm going to discuss today is the version 2 of this document. We started putting together way back in November of last year, and then we published the version 0 right around IETF 98, and after that we had 2 more revisions on that. So this draft is basically how do we deploy ICN natively in a cellular mobile network, which can be LTE or can be 4G. So the main boundary for this one is LTE network and how to deploy ICN natively. We have been discussing quite a bit, and there are a lot of thought-provoking that why do we need a new draft? What is so different about this ICN in the cellular mobile network? So based upon some of our discussion internally with some of the researchers in this area, as well as my experience, particularly in the mobile network, the first thing is that when we so far, the ICN has always been done as an overlay protocol in the sense that the endpoints are having IP addressing, and then after that they are establishing the message flow for the fetching the data using the ICN protocol. The second thing is most of the ICN work is either in the fixed wireline or in the Wi-Fi area, but no work has been done in the cellular. So this draft addresses that. And the third aspect is that there is so much of characterization of video in the mobile, and most of the content which we download is video, which is the biggest benefit for ICN. So we wanted to do some research and get some understanding on that. What you see on the right-hand side are the changes taken place in this draft since our first release. Luckily, we got a lot of feedback from you all and also from Dave Oran in particularly. And it took almost like 3 months for us to go back and then experiment it again and see what we can put our findings. So when you look at the version 2, you will find quite a big difference compared to what we had in version 0. I want to cover very briefly about how we envision this ICN to be deployed. And we are also working very closely with 3GPP. So some of the findings what we come up here can go into the specifications development for 3GPP. So my colleagues from Cisco who are working on 3GPP, they are taking some of our work and proposing there. And I look forward for partnership from the community and all other researchers in this area, so we can kind of propose in the 3GPP as well. The first key aspect in terms of the UE or the client or the device which is trying to get the content, what we are proposing is that we put a in order to put this ICN inside the mobile protocol, what we can do is that we can have a transport selector as a layer, and this transport selector is nothing but it's an ICN forwarder, and it can do very two important functions. The first function could be it can help decide whether the data should be sent using the radio protocol, say like LTE, or this should be done using the Wi-Fi, or this can be done using both based upon additional prioritization. And second thing, it could be also based upon content type, content preference. So some of the logics can be built into the transport selector. So that's the function for that. And I got a lot of comment around this. In the version 0, the name was different. It was not transport selector. We had a ICN forwarder, but we decided that transport selector will be more generic around that. The second part is that at the network layer, we want to introduce ICN function, and that will coexist with the IP. And both of these functions will have a interoperability with the transport selector on the top and what we call a PDCP layer at the bottom. One of the most important function is performed by the PDCP layer, which is basically doing the header compression, decompression, encryption, as well as formatting the message coming from the application layer so it can be sent towards the radio. And that layer has to be modified. The draft contains a lot of detail about what all changes supposed to be there into the PDCP layer. So these are the three layer we are proposing to make changes. Rest of the lower layer like RLC, MAC layer or PHY layer, there is no change around that. They will remain as it is. So that's the changes in the UE. Then the second aspect, again, in this draft, you will find a lot more changes around the E node B or the base station. So what we are proposing here is that the radio should be the ICN forwarder. And the way it should work as ICN forwarder is that the request will come from the user on the radio interface. It will come to the E node B. And after that, it will have a logics which can work in the three different ways. The first one will be, it can simply handle the ICN request, and if the ICN transport is available, it can send the request on the ICN transport. The second thing could be if the user is requesting based upon the IP, and if the IP is available, it can send, or if the user is requesting either IP or ICN, it can have additional logics based upon parameters, and then it can send it out. The key part is that even the client is requesting like IP, and IP is not available, is there only or the ICN transport, then you can send IP on top of ICN transport or vice versa. So, and also we want to provide a capabilities where you can program the E node B based upon certain type of transport available. So we are proposing a northbound API from the management interface on that. The third part, what we want to do is that right now most of the transport between the radio and the gateways is all IP. But we envision that in future there might be a dualistic scenario, dualistic in the sense it could be IP and ICN both, or in certain part of the network this could be just ICN. So what we are proposing this is that we can implement this ICN in the transport part, and eventually this will help in removing some of the encapsulation tunnel. So those who are familiar with the mobile network, you will know that there is a tunnel called GPRS tunneling protocol, GTP tunnel, and this tunnel is basically kind of a hub and spoke. From every phone connecting to the gateway, and it's kind of having a virtual tunnels for each of them. Our idea is that when we are able to implement ICN natively, probably we don't have to do GTP, or if we do GTP, it will be very, very locally, because there is also work going on in the 3GPP where you can move the user plane of the gateway right at the edge of the network. So the intent for this slide is that you can implement ICN natively or dualistic in the entire transport from the radio all the way up to the gateways. And there again, we envision that there has to be a northbound API, so you can influence certain decision based upon either transport's availability or some additional criteria like a cost or congestion or QoS and like that. Then we have been asked after version 0 that what about the security? And the security for the mobile is quite different comparing with what we have seen for the ICN, and this part hasn't been addressed very adequately. So what we found out that there are 7 key aspects related to the security. The first one is the user or the phone authentication and authorization. The second part is the security related to the radio interface itself. Some of them have been addressed, but when we suggest that we are going to modify the PDCP layer, basically we are going to relook at the security which is implemented for IP. It has to be there for the ICN as well. And then the third part is the DDoS attack for the mobile gateways or the services which are being offered. And if it move to the ICN, how to protect those areas. And then the rest 4 in terms of the content poisoning, in terms of the caching, and then pollution caching, and also related to the naming, routing, forwarding, and application security. What I want to propose is that based upon our last 3 months work, there is a lot of questions around security than the answers which you could find. If any of you are working in this area and want to provide some more input, I really welcome, because after I got feedback from our version 0, we realized that security hasn't been addressed adequately, especially in terms of the mobile scenario. Even though the 2 specifications what are highlighted here, TS33310 and 320, they cover purely about the first 3 part, but the other 4 key aspects hasn't been addressed at all clearly. Also, when we implement ICN, there is a something called lawful intercept, where the legal agencies should have access to the content being fetched and who is doing what kind of content fetching. So for that, the security research is required. Even though in IP there is a lot of protocols through which this information is sent to the lawful agencies, but in case of ICN, the scenario will be quite different, because we cannot use any of these protocols anymore. Then what we believe, based upon the work so far, is that maybe it's a time for you guys to help us with some more collaboration. And also I want to request the chair, it will be really good if we can adopt this as a working draft, so that way we can get more feedback and we can make quick progress on that. So with that, I'm open for questions.
This is Akbar Rahman. Thanks for the update. I had read a previous version and it was good. Akbar, AKBAR. I had read a previous version and it was good. But the one comment, if you go back 1 slide to the security, please. As you know, I'm going to be presenting the deployment considerations next. And I had a similar question to look into security. And what I found is that RFC 7945, the one that had been done in this working group with security considerations, actually covered like some of these issues. So I don't know if you've already scrubbed through that.
I went through that. I think we still need to get some more information around that. So
I agree there's more to be done, but that was one place,
Yes.
I think, because you said that you were looking for previous sort of references to that.
yes, thank you.
So I think that's if you could you go back to your previous slides, one more. Yeah, the one more with the UE, where you had the UE stack.
Yeah.
So I think, so essentially, if I understand correctly, you're proposing the dual stack approach, right?
Yes, yeah.
And so the ICN function new, that would be, when would you use that? That would be if you had 4G deployment that was fully upgraded to ICN?
So if you relate it back few years back when IPv6 came into the network, we used to have only IPv4 at that time. And then when IPv6 was introduced, they introduced some fun capabilities where when the client in the sense the UE attached, it can indicate a preference that, hey, I want IPv6 or IPv4. What we are proposing through this draft is that now is the time to do exactly something similar, but we can introduce ICN in addition to the IP. So what it entails is that when we introduce this ICN function along with the IP, this will help UE to indicate its choice that, hey, I want to attach to the network even as an ICN client in addition to the IP. So,
Okay,
so that is the
Okay,
goal.
so it would be UE initiated.
Yes, yes.
Okay, good. Thank you. Thank you very much.
Yeah. And if I can make one more quick comment, I went through anchorless mobility quite a bit, and we did some experiment on that. But especially when the user is attaching to the cellular network, it has to indicate its point of attachment. And that is what this slide is trying to explain, that when you power up the phone, when it attach, first time it has to indicate that, I'm a ICN client, and that is how I'm going to do all the protocols in terms of the transport of the data.
Okay, thank you. It's a good draft. Thank you.
Yeah.
Hi, Dirk Trossen, InterDigital. I have a question about I do like the draft a lot. The dual stack, I think is really good. It's good to integrate it into LTE. The question I have is about the top box. You talk about existing applications, and you slot the transport selector in between to just dispatch to the different stacks. But I wonder, do you believe a transport selector is really what's the key issue, or isn't there, some form of, semantic adaptation that's required? Existing applications like an HTTP-based application, merely selecting the transport would be enough, or is there anything else required?
So if you look at the, so let me go to the next. Sorry, 1 second. Yeah, if you see this slide, this is not the exact replica, but this shows the high-level protocol layers between the client on the left side and the nodes on the right-hand side. So what we used to have is that the application, which are actually either requesting the content or consuming the content, and then all they need is the socket, either TCP or UDP socket, to connect to the IP layer and send it out. Now what we are trying to do is that we are trying to introduce one additional mechanism in addition to the existing IP. And also we want to create some form of a preference, like tomorrow you might have some app where you say, I want to use only ICN. And another person say, I don't care, ICN or IP, but if the QoS is better in any of them, I want that. So that is what we want to propose, that using this transport selector, you can have all this kind of mechanism built into that.
So you're treating ICN as a pure channel between A and B. Okay.
Yes.
Good. Thanks.
Yeah. Thank you.
Hi, John Dowdle from Airbus. I'm pretty new to this group, so sorry if this conversation's already been had before. I work quite a lot in DTN, delay tolerant networks, where we have the concept of using any old transport layer and then the bundle protocol that runs over the top of that. Bundle protocol being the thing that actually holds all the payload. Now, what we have between the two is a concept of a convergence layer. And what that does is that adapts the bundle protocol to whatever transport it is that's running underneath that. Now, I'm sat there in my head trying to reassemble your diagram that you've got on the board here into something that DTN would understand. I can't quite do it in my head at the moment, but I just urge you to have a look at what's going on in DTN in terms of the architecture, and just see if there are concepts that you can borrow to help you along this path. Okay, because I think the concept of a transport select is kind of implicitly defined in DTN.
Okay, okay, thank you. I will go through that. Actually, it was not transport selector earlier. I had a name as an ICN forwarder, and then when we had that ICN forwarder, we were thinking we are kind of boxing ourselves only to the ICN, not giving an additional option for the protocol. So hopefully this transport selector is a little more open with more choices to determine how the packets can be forwarded from the user.
Yeah, and I'd love to be able to look at running ICN over DTN, actually. I don't know if that turns your architecture upside down, but I can see that there are good synergies between the two.
Okay, okay, sure. Thank you.
If I can just inject something here, so it's a good comments. Parts of the ICN community, I think, also have a bit of DTN background, and there's definitely also a relationship and things that can be learned. There has actually been some work on running ICN over DTN. So I think Stephen Farrell and folks actually have submitted a draft once on that.
So thank you very much again. And my request to the chair again, if this could be adopted as working draft.
Yeah, thanks a lot, Prakash, for the presentation and also for the update, considering the feedback that we got. So we see quite a bit of interest in this work. So question to you, do you currently have, say, sufficient ideas to do a new ref of this one? So is there anything in the pipeline that you would still want to add? I mean, you got some questions, comments today.
Yes, so answer is yes. I had a lot of feedback from community as well as from my company as well, because I'm from Cisco and they have a lot of influence around that. So yes, we have a lot of additional input to work on top of what Dave and then team sent to us. But my request is that if we adopt as working draft, probably I'll get a lot more collaboration. So
right. So we think this is probably of sufficient interest for the group at large. But let's do it like this: that can you provide a next revision, and then we normally how we work is that we have this adoption discussion on the main list. So people basically raise their voice and express their opinion. Whether this is, say, sufficiently mature to be adopted and so on. So we normally we kind of go figure out the interest in the room here, and then we do the discussion on the mailing list.
okay, okay.
Well, I also would like to ask the room and the people here to provide another round of comments and reviews of this document before you do that revision. Do we have anybody that would be willing to review this document within not too distant future? Okay, we have two people down there, and Dirk. Yeah. So okay. And Greg. So Dirk, Cross, and Greg, Ravi, and Akbar.
Yeah.
Yeah. So that would be really great, and anybody else. And also, as this has a lot of part of LT and the mobile thing, I would ask people who have colleagues that's working closely with the mobile, if you could ask them to have a look at this and see if they think this is a reasonable approach. I think that would be very valuable input for us on this.
Okay, yeah, thank you. I have kind of tried to demystify a little bit from mobility towards the IETF, and I also tried to demystify a little bit from the Icnrg work itself. So it's, this current draft, I think it's a good enough where everyone can understand and then provide comments.
No, I think it does a very good job on that, but the more comments we get, the better.
Yes, yeah. Thank you very much.
Thanks a lot.
So next would be Akbar, an update on the deployment guidelines document.
So I'll just have to get it up.
Is it good? Do I have to switch it to the new?
No, I'm just working on it too. So where did it go? This one we don't want. It's difficult when you don't see the screen. Come on. Okay.
Okay, thank you. So my name is Akbar Rahman, and I'm presenting on behalf of my co-authors, Dirk Trossen, Dirk Kutcher, and Ravi. And the title of the draft, as you can see, is Deployment Considerations for ICN, and this is the second revision. Just to give you some background, as you probably all know, the Icnrg charter clearly identifies deployment guidelines as an important topic area for the community. And specifically, the charter states that defining clear migration paths for deployments and defining practical interworking with the existing internet are two key topic areas. And we felt that really we didn't see much literature or drafts. There was a very early draft several years ago that there was a Rev 00 on this, but not much other work. So we thought we should write a draft to address the topic, and this is it. The revision history, we presented Rev 00 in Chicago, and we received a lot of good feedback verbally during the meeting. And soon afterwards, we updated it to address all those verbal comments from the meeting. And then Dave Oren kindly did a very detailed review and gave us a lot of comments, and we addressed that in the Revs 02 version here. So what I'll do basically go through the key changes we did between the initial and the current Rev. So the first thing, I think it set the stage for the whole draft, so I'll just mention it here. Initially, we had the draft title as deployment configurations, but the feedback given to us is that really, we're not looking for a formula book or detailed guidelines. What the draft was trying to cover and what people wanted to see was more meta guidance on how to deploy ICN. What are the different configurations possible? What are the challenges? How do you interwork with the existing internet? So we did this subtle change to the title, but I think it reflects well on what we were trying to do. Second point is, I have it just here listed, as you can see, by sections. So second point is we were asked to rework all the definitions because we sort of, made up new definitions of ICN, NDN, etc. Some of the key terms. So it made sense to rework that and refer to the existing ICN terminology draft when possible, and or other RFCs. For example, there's RFCs for SDN, etc. So in general, the only new definition we have in this section really is for what we mean by deployment itself. And for that, we had a short definition, meaning that we were, in the context of this document, deployment means integrating and interworking an ICN network with the existing internet and being able to do useful end user work. Basically, be able to send and receive content for real life end users. So that was the update to the definition. Then, as you'll see, we have several basic configurations that we've defined, and one of the configurations we have is the ICN in a slice. So basically, usually referring to the 5G version. And this Ravi was kind enough to give us a lot of new text in this area because he's the expert on this. And in a way, it of course ties into the previous presentation, which was about ICN and 4G. So we were looking more ahead forward to the 5G version, which is the ICN in a slice. So a lot more details added there. Thanks, Ravi. The deployment trial experiences, we updated it to make it more clear and map to one of these existing configurations that, again, I'm going to describe in a bit more detail in a few slides. But we grouped it under the appropriate overlay or underlay category in the deployment trials. We also added a new trial summary, which was for ICN 2020, and they support both NDN and CCN versions. So we added that. And one important comment that we had gotten from several people in the meeting, and also later on from Dave, was that that in this draft we should clearly identify the functionality required to enable interoperation with existing internet. For example, the fact that HTTP or CoAP messages must be mapped to ICN messages in certain deployment scenarios, or that dynamic naming must be, more clearly specified in the community. Also, we had we identified a few. I think it was a list, a fairly short list of 6 or 7 items, and basically what we clarified technically what these items are that require potential protocol effort going into the future in IETF, but we removed all references to actually trying to identify working groups or BOFs, because as Dave and other pointed out, that's really premature, and that can be done in a second step. The main issue is really identifying the work that has to be done. So that was one more major change. Then we expanded the conclusion really because it was skeletal at that point, so we tried to make sure it covers the major conclusions from all the different sections. And we had, as in the previous 4G discussion, we had a lot of comments about that we should have a security consideration section that was filled out, because in the initial version it was just empty. So I had to think a lot about this, but fortunately I saw RFC 7945, which, as the title suggests, already covered a lot of security considerations. So I read through that carefully and identified the ones that were relevant to deployment. For example, they identified that ICN network capability to resist DOS attacks, for example, still is at its infancy. They also identified the fact that the security of the in-caching units in the network still is at its infancy. So these are practical issues that have to be addressed before real deployments can happen. And then we ourselves added some text, basically centering on the fact that ICN, of course, has very good built-in authentication and optionally encryption properties. But if you want to really interwork with the rest of the internet, you can't just consider the security within the ICN. You have to have some end-to-end context for the security. So we identified that that's one issue that has to be really looked into a bit more. For example, if an HTTP message comes and you interwork with ICN and send back a HTTP response, what is the end-to-end security context of the whole thing? So those were the major changes. Any questions so far? Did I miss anything that anyone had asked? Okay, good. Then just to highlight here what's actually covered in the draft. So the terminology, as I mentioned, we start off basically by identifying the key deployment, what we call the deployment configurations, and really it's 4 major ones. There's the sort of so-called greenfield, the initial ICN idea where you would replace everything with ICN. So we call that the wholesale replacement. That's, of course, practically going forward, and from what we saw from the experiments, the least likely. Then we have the 2 other ones, the ICN as an overlay, where basically a lot of the experiments, for example, have been run as an overlay. So that's definitely one configuration. Then there's the ICN as an underlay, where basically you'll have either at the edge or at the core some basic ICN fabric, including perhaps running ICN directly on layer 2, and then you'll do that mapping at the ingress and the egress of HTTP, CoAP, or whatever the protocol used in the rest of the network and in the devices. And then we had the ICN in a slice, which was really addressing the 5G version of supporting ICN in cellular networks.
Thomas Schmidt from Hamburg. What I missed a little bit in your first of all, thanks for all these enumerations and for this work. But what I miss a little bit is the activities that have been done about ICN over wireless, and in particular about lossy, low-power wireless networks.
Can you refine the question a bit more, because I'm.
Well, I mean, there has been work, and we have done some, but others also have done to experiment and try deployment of ICN on in test beds on wireless, and in particular on low power wireless. I mean, not the strong links, but the weak links.
Okay,
that is just a pointer to maybe you can add something about this.
Okay, so that's a very good point. So I guess it would fit, Thomas, if you could stay for just a second to make sure that I understood your comment. I guess it would fit in the section 5 deployment trial experiences, because there we tried to list, the major flavors, CCN,
exactly,
NDN, etc. So what I'll do is I'll take an action to talk to you and find the references, and we can add it definitely in. We were actually, in previous meetings soliciting input for that, so thank you for that. I'll take an action for that.
Yeah, sorry, just a very quick comment from my side, Crossen again. I actually suggested the reference is too late. I know they fit on their Edge network. We had a discussion at our recent project plenary where one of the project members pointed it out, but we had already, I think, submitted the 02, and I didn't want to push another 03 in there. The list of references can be significantly extended. I think we're all aware of that, and if people just look at the categorization, and it almost, I think, Dave, you suggested that at some point you're having this almost like a living document that kind of like grows in references and things. This is by no means complete. I think we are aware of that, but I should have told you that before that it was mentioned. That was my mistake.
Okay, no problem. Thank you. So we'll take the action. We'll talk to Thomas, and of course, Dirk is a co-author. Even I guess the work that Prakash had presented, we could somehow reference that in here, because I think we have the ICN in a slice, but we didn't. That was more specifically oriented to 5G. So if we wanted to add a 4G reference or somehow tie it in either as a deployment trial or something, I think it would be nice for completeness. So where was I? Okay, so then the next major section was the deployment migration paths, and here basically we answered the question. What are the key issues that the entity deploying the ICN would have to consider when they're deploying into the live network? So basically, we categorized it into 4 major areas. Basically, application migration. So do they assume new applications that are ICN enabled, or do they assume existing applications that somehow have to interwork with ICN? Then there was more specific network components, which was basically CDN, as we saw from the literature and from reviews and discussions, is a key use case probably for ICN going forward to be deployed, because it is basically anyways caching and based on names, so it has very many similar properties to ICN, so it's probably a good candidate for ICN deployments. And then we had, and then also, what are the issues for edge network and core network deployments? The next major section was the deployment trials. So here, we had solicited previously and still do. We'll add in Thomas's suggestion for the wireless, low power wireless stuff. If there's anything else that anyone, any other interesting trial, well, we were staying away from simulations. So we were really concentrating on actual trials, and from these trials vary from a few devices to, in some cases, hundreds of devices. If you read through the summaries, you'll see that. And then the final main section was we identified the interworking issues, because the whole idea here is that we're trying to give guidance on future deployments, considerations for that. And one of the I think the obvious things the industry knows, and we try to codify here, is really what are the key protocols that we need to affect, whether they be, for example, for multicast distribution, whether they be to support existing HTTP co-op, whether they be to do the mapping of these messages, etc. So, go ahead,
Hi,
please.
I'm Eve Schuler from Intel. I was just curious, in your research of all these trials, you said they range from just a few nodes to hundreds of nodes. Did you get any trials that you're aware of that are experimenting with more sizable, even more sizable ICN deployments? Because I think that might actually be an issue for the for the later section about known gaps. That, you know, is that a large enough deployment to understand all the gaps even?
Right. I think it's a valid question, but we just looked at the corpus of information available, and really we didn't see anything that was in the tens of thousands, for example. If I've missed it, I'd definitely like to be told about it, but I think it was really in the order of, I think the biggest was probably in the low thousands.
Okay.
So that seems to be the range of.
Yeah, so really my question is, like, as a community, is that a big enough deployment for us to understand even the gaps, and how do we get to that next level? And it's not necessarily for you per se, but for the room.
Yeah, it's a very good question. On the other hand, I think something that alleviates the concern a bit is there was so many different approaches. So there was like NDN, CCN, there was overlay, underlay. So they looked at I think the problem has been looked at from many different angles. And as we saw in the chair summary, some of these protocols have been so well tested that they're now going to RFC. So I think that gives a slight bit of confidence.
Okay.
Yeah, Dr. Rossman, if I might follow up on this, I think the scale issue is really one, but that's an identifier issue. But when it comes to deployments in ICN, I remember a very strong remark of one funding agency about 3 years back on scale of ICN research. And I think at that stage, there were tens of nodes. I think a lot of it has to do, obviously, with the software engineering, I would argue, the readiness of software. One of the plans that and I think we actually have the flame efforts listed there as an underlay, and that's simply driven by software engineering through virtualization techniques, is, have a deployment on a stick being pushed into the Amazon cloud and scaled up to potentially, depending on the budget, really, because you pay for it, but thousands of nodes. And some of the considerations on gaps really will come out then in these type of deployments. But the point is, a lot of the software that will be utilized for that is either heavily software engineered on the ICN side and utilizing platforms that are heavily software engineered. I think that's a real issue when it comes to scale. But that leads me to another remark I actually had about excluding simulations, as we had a discussion, and I fully agree to that. But there is a thing in between, and we have one reference actually in there that is in between, and that's socioeconomic studies on transition. And that's the Tyson reference that we have in there. It used to be reference number 1, but now they are obviously one. And what this one was actually looking at is a large-scale migration, and it's actually very much related to the LTE draft, because it was considering a dual-stack deployment and a transition from overlay and native existing towards a native ICN deployment kind of thing. Now, I think to me, they're still relevant, because even though they're not deployments, but they are deployment-oriented studies. And I do know, but I couldn't remember the reference. I know the NDN project has at least done another study, and I have to look it up because I used to know it. I might find it myself. But these, I think, would be things quite interesting to put in, because they're obviously very focused. They're not, testing a protocol in scale, but it really looks at transition, certain migration parts. So we focus in this work, for instance, on core and edge network migration, etc. And that could be quite relevant as references, I would argue. And Licia might know what that reference is, because I do know the work.
I apologize, I didn't pay full attention, but I heard the word NDN being mentioned. I figure I should come here, do a clarification. I think our work is not so much of a transition, because we believe the most advantages of a new architecture can only be explored by designing an application that actually take advantage of it. You try to transit an existing app to run over ICN. I'm not confident you actually get the most advantages. I think this relates to all the things I've heard so far, like about the first one. Is that the first one? I hope it is. On the 5G deployment, I saw that slicing the ICN just below the transport. That will be a very long discussion that I don't want to, take your time here on, but I'd be very much like to chat with people afterward. I have a pretty different picture. Thank you.
Thank you.
Do you want to respond?
Just respond briefly. In the deployment migration paths, the section 4 is where we try to identify the issues related to, as the name implies, deployment. And we clearly identified application as a key area that has to be looked at. So do you assume that the applications, as I mentioned previously, are ICN enabled, or are the existing application that have to be adapted? So just to respond briefly, and Dirk, go ahead, please.
Should I? Okay. Existing applications can benefit greatly from ICN, but given that they were developed on top of TCP/IP, or at least on that, point-to-point address-based delivery model, and without the security actually intrinsically built in, my personal view is that they will not be able to benefit fully. And so is the transition about, putting ICN just, as an IP replacement. I wasn't sure that's the picture I would share. But again, it's a very long discussion. I don't want to start here. Thank you.
Yeah, thanks.
Because it's not on the agenda.
No, but it's a good comment. So on the other hand, so also regarding the LTE, ICN LTE draft, it's not that we are like exclusively endorsing, say, one approach versus the other, but this is a research group, so we are discussing different, ideas and views on that.
Oh yeah. That's why I'm saying that's for discussion.
Yeah, and absolutely. And we should really investigate this more, right? So also the potential of developing applications differently or new applications.
Thank you. I know I'm running out of time, so I'll go quickly. So I think I can go to the next slides. These I'll go through quickly.
Just one comment on there. On the gap thing, there you have HTTP co-op support of ICN semantics. I just want to point you to in the SAIL project, we did a demo, an IoT demo where we extended co-op with minor things to support the netinf semantics. I'll point you to that one.
Thank you. I know Dirk had already put in some text about netinf, so but I think this might be missing, so we'll add that in definitely. Thank you. Okay, so just to go through the deployment configurations, I sort of had covered, I think, the main points, but just to go through it quickly. So basically, as I mentioned, it's a considerations draft, trying to give some guidance as to what to look at when you deploy ICN, what are the issues and what are the possible approaches. So the first thing we started off with is actually identifying the configurations that we saw from all the different publications and experiments, etc. So as I mentioned, the wholesale, really, most ICN projects start off considering wholesale or clean slate, but practically speaking, they'll often migrate to one of the other two, which is first ICN as an overlay, sometimes referred to as tunneling loosely. So you have various flavors of that. You can have ICN sent over UDP. You can have ICN names mapped to IPv6 addresses. You can have some sort of convergence layer to map ICN semantics. This, I think, relates to the previous point from Borge. You have ICN as an underlay. So here, really, you would have ICN infrastructure islands either at the edge or the core of the network. And then through gateways, essentially, or network attachment points, at the ingress and egress, you would do protocol mapping. So some examples are given there. HTTP co-op IP onto core ICN messages, core network ICN messages, edge TCP IP to core TCP ICN messages, edge ICN messages onto core HTTP co-op IP messages. So you have many different combinations possible, and we saw from the experiments and the papers, etc., that many different avenues are possible. And this particular configuration is really interesting, for example, for CDNs or for IoT at the edge, because you could, for example, leave the rest of the network not ICN enabled. You could start off with just an edge IoT deployment and expand out from there, I guess, as time goes on. Final one, the ICN as a slice. This Ravi had done a lot of work. So basically, the idea is, with the famous 5G network slicing, to deploy ICN there. Either it could be on top of IP or layer 2. There's many different possible options.
Yeah, I waited until you show all the 3 slides to see if the point I care most showed up here. I think it's not there. Okay. This is actually echo back a comment Thomas made earlier. That is the native ICN running directly on top of wireless and having application directly on top of ICN. I believe that actually is a picture suggested by this ICN1 program that Yu Schuler has talked a few times at this meeting. I think that actually, to me, is the most exciting trial environment that can fully exploit both the ICN advantages and fully utilize the modern and also heterogeneous wireless technologies. I couldn't match that vision into any of your 3 slides.
Dirk Rossen, if I might disagree, the dimensioning of the draft is that it outlines at which part of the network the migration happened, which means ICN over wireless is the edge network. That's in the draft. Now the reference are missing. We said that we had the references. Pure ICN applications is in because you're doing application service migration. In that case, you simply don't migrate. You do new applications. We specifically point out new applications, which, by the way, obviously, one of the issues maybe of the Icnrg, the new applications really have been missing for many years. We haven't really seen too many exciting ones, but that's a different issue, right? I do believe they're both in. The problem is you have to read the draft multidimensionally, right? There is application and service migration happening at various parts of the network, and therefore your IoT scenario over wireless fits into application service migration at the edge network. So it is in. The references will be added. But the point is also, I'm sorry, that the excitement of ICN work happens in deployments in different parts of the network. Not everybody is as excited maybe about core migration. I can understand that, and maybe some people will believe that ICN at the edge is the most exciting thing, but the draft is supposed to cover the different migrations as they happen.
I'm going to cut in just because I have a piece of information maybe relevant to Alicia here, which is that at least one of the teams working on the WEN project is explicitly looking at running ICN over a slice on 5G. So at least one of the approaches being done in ICN WEN is exactly the same as what one of the deployment options here. Yeah, there are other approaches. Yeah, if you want to contribute to the draft, that would be really great.
I just want to back that up. I mean, when you say ICN as a slice, you're bringing ICN as close to the eNode Bs. So in that sense, your 5G RAN is simply only the radio link. And you could actually do mobility on top of ICN. So, I mean, I don't think you're missing anything. I mean, if you've probably even listened to the talk yesterday on 5G from the 3GPP folks, it's a most kind of flexible architecture that you have there. There's no custom gateway functionalities and such like that. So this is one opportunity that we see where you could actually take an ICN and do something useful with it rather than just doing an overlay. This is Ravi from Huawei.
You want to cut me off?
If it's quick, then, I mean, I think it's understood what you want to say, but okay.
Okay, if you don't cut me off, let me say it. I'm so glad to agree with Dr. Charlson on disagreement.
Yeah.
That is the mentioning to say ICN can run on top of wireless and then period is not the picture. I tried to comment earlier. Maybe I didn't make it clear, but that's not the picture. I think it's really there is a new way of trying things out. The ICN is the app ICN wireless, and that is the picture. If you just say you segment the picture to say, oh, ICN on the wireless, and then on the other side, I would say ICN on top of, I don't know, ICN and transport, so-called the transport of today, and then you build applications. That's a very different picture. I also want to reply to Rafi that I understand 5G has their own visions of the pictures, but there's also, you can look at the world from different angle. From my angle, your 5G is nothing but one of the wireless. You know, my phone, my current phone can use your 5G, can use Bluetooth, and can use Wi-Fi simultaneously. And that is a more complete picture.
Okay, thank you.
I think I'm basically, maybe I just go to the next steps here. So I turn it over to you, Dirk.
Okay. Well, I think that was actually quite a useful discussion, to be honest. I mean, so basically, I've seen that there are really, different perspectives of the ICN deployments, and so this draft lists, I think, quite a comprehensive set of options. We also got some additional feedback, so I think there's a potential for us to do another ref on this. Would you agree? Or?
Yes, yes. Well, definitely, I think we have to do another rev. I don't know if you want to address, the comment that Dave Warren had made with the share hat off, whether to adopt it now or in the next rev. I don't know if that's.
Well, I think, this is really okay, maybe I shouldn't handle this as a co-author, to be honest.
Okay, so my proposal is as we do the same as the previous draft, that we ask people to continue to comment now in a short time. You do another rev of the document, and after that we take it to the list to see if the group feels it's ready to adopt this as a working group or research group draft. Would that make sense?
Correct. So, how many people have read the current rev of the document? Some. One other way we could deal with this is we could just get more comments on the current rev so that Akbar doesn't have to issue 2 revs, right, before we look at adoption. So we can get some more comments and then get a rev out of that and then look at adoption. Rather than issuing yet another version of the draft now. That's all.
No, that was not what I was proposing. I was proposing to have more comments now, and then do a rev. And when we have that rev, yes.
That's what. All right. So we're suggesting exactly the same thing.
Yes.
Great. All right. So if the ball's in your court, ICNRG participants, let's get some more comments on this draft so that we can move it forward. Yeah.
Jan Seedorf, I just wanted to make the point that, maturity is obviously an issue, but the other question for adoption is, does the research group think this is interesting stuff that the research group should publish? And I certainly think it is. So, from my perspective, certainly this is something that we want, that is useful to put out. So, yeah, I haven't read the latest document, so I cannot comment on the actual maturity of the text, but that's for me a secondary issue, actually, right? The primary issue of adoption is always, does the research group think this is work we want? Of course, then the question is, are there competing approaches or documents, which in this case, I don't think it applies. So certainly I would support moving this ahead and eventually adopting it. Yeah.
Thank you.
Yeah, we can ask how many people in here do you think this is a relevant document to have for the research group? Yeah, so we see a fair. Yeah, so we see a fair number of hands showing for that. So and maybe we can also ask if we have any people who would volunteer to review this latest version of the draft. Do we have any names that would be willing to do that? Per? Okay. And do you know? I don't remember your name. Give the Dirk. Yeah.
Okay, can I have just one request to the chairs? Can we put a time frame, because then we can make sure we do a good update well before Singapore.
Yeah. And my idea with asking for reviewers, I think your main go ahead would be to get those 2 reviews in, and whatever you got by then you can issue the next one.
Okay.
If you need us to bug people, let me know and we'll go bug people.
Okay. Thank you, everybody.
Where are the blue sheets, by the way?
Yes.
Who hasn't signed it? Okay.
Let's send them around one more time.
All right.
So,
So Jan,
Jan.
next. ICN in disaster scenarios.
Right.
Like right here.
Like, say again? I didn't get it. What? Disaster? What is a disaster? This group. Anyway, so I think so. Maybe next slide. So this. Oh no, maybe you stay on the slide. So actually, we received a lot of comments from. A clicker, so I can move the slides ahead.
Yes.
Oh, cool.
Magic.
Cool. So the first thing, and maybe I start with the title. We actually had the same issue at the last IETF where the chair suggested somebody should actually give the draft a thorough read, and Akbar was so kind to do that and provide us with a lot of comments. So Akbar, you posted the comments on the list. I replied on the list. So, but the main goal of this presentation is to summarize it, your comments and how we address them. So if you feel in any way what I'm saying was not your comment, please come to the mic right away and we can discuss. But the first comment you made was actually the title, and I actually agreed with you. So renamed the title to Research Directions for Using ICN in Disaster Scenarios. The old title was just Using ICN in Disaster Scenarios. But since this is a research group document, I just wanted to make the working group aware. So we think this new, actually good suggestion, we changed it. But if people feel it's not an adequate title, just, let us know. I think it's a good title because it's more, this document is more or less like a position paper, right? We're trying to argue that ICN is good for disaster scenarios, and we give some research pointers. So yeah, with that, maybe, yeah, I can do it. So I just want to go quickly over this slide because I've presented this multiple times. We have, a lot of people have been working on applying ICN technologies to solve an issue like you see in the picture, where after disaster, a network has lots of broken links, but you still want to be able to communicate with each other in a DTN type of fashion. So we looked at several key use cases. They're all in the document, so I don't really want to go over this too much because I presented this. Who has not seen a presentation from me on the disaster document? See very few people. So because I presented multiple times here at Icnrg, if you really want to get more information, just read the document. There's a lot of text in there, so I don't want to bother people. Just a reminder of the history, we had a lot of initial versions over the years. We had actually a research project mainly working on this use case, and this is an output. Over the years, we got various feedback. One big concern was from the DTN people who said, basically, this is our turf. Why is ICN now in our turf? And we've added a lot of text explaining why we think that actually ICN could also be a good starting point to address DTN-style communications. It has been adopted last year. And like I just mentioned, the chair said, well, to move the document ahead, why don't we give it a thorough review? And Akbar was so kind to do that. He gave multiple comments. We think we addressed them all, or the ones we didn't address, I replied on the mailing list. So the rest of the presentation, I just want to go over the changes one by one. Since I'm a lazy guy, what I did is cut and paste the diff from the web page. So yeah, that's anyway. Huh? Well, so I was mentioning this. It's a new title. This is. Say again? No, no. The important point is a new title, right? Research directions. Yeah. Sorry. Anyway, I mentioned this already. So this was a suggestion we took. This was actually a good point. We talked a lot about how you want to do disaster communication with ICN or how you can do it. But Aqua made the point that actually in existing mobile networks, there's also some services out there, right? You can do cell broadcast, you can send SMS notifications out to people if there's a disaster. So I think, Aqua, your point was to just mention these existing services to say, okay, even in today's mobile networks, there are some services, but you know, if the network breaks down, maybe you want to. You have a comment, Dave? No. Okay. So yeah. So we took this as a good comment, and we added some text, as you can see here. Another point is we talk a lot about security and authentication in the document. And in fact, also this was a very good comment. There are services. So the old document read like, well, if you're offline from your centralized servers, you can do nothing in today's mobile networks, and that's not entirely true. And you made a very good point there. Of course, there are some services. Everybody knows about the emergency calls, right? So even without authentication, there are some services available. I try to highlight here in the text that there are certain things that you still cannot do in today's network if you don't have access to an authentication server, and those are the kind of things we think ICN can do better. So one of the things would be like you're a user, you want to inform authorities, and you still want to be authenticated, and these kind of things. So we added some text here too. Yeah, and this is actually the one comment we didn't agree on with you. You said the list is not exhaustive. There certainly should be more things. And I actually had some old text in the document saying, yeah, the list is not complete. We actually think at this point, the list of ICN benefits we listed is rather complete. And we basically think this document should not be a living document until, you know, we found all the possible ways ICN can help, but rather like a position paper arguing some key points. So actually, I removed that text and I replied also in the mail. Yeah, and this is actually the one comment that triggered a lot of discussion among the authors of the document, because you were saying, well, you talk about, so Akbar again, right? You said in one of your key comments, well, you talk about communication after disaster. The one thing people want to do after disasters, they want to make a voice call, right? So how does that fit with ICN and everything? And well, I mean, if you read the text, again, it's highlighted here, the new text, we envision that if you have a kind of scenario where the best you can do is DTN-style communication, you cannot have real-time, full duplex voice calls. Having said that, of course, and we put a pointer here in, there has been work on doing voice over IP style communication over ICN. I mean, how do you call that? Voice over ICN, I guess, or so you can do real-time communication over ICN. But in the scenario we are considering, we think that's almost impossible to do. Having said that, again, of course you can do, and this was a cool comment from some of our co-authors, that you, of course you can do voice messages like WhatsApp has, right? So why I might not be able to if I want to reach Cedric, I might not be able to have a phone call with him, but I certainly, with the communication we are considering, the model we are considering, I can put out a voice message and eventually it reaches him. So in short, the answer is you're making a good point, and it's good that we added some. I think it improves the draft that we have also now addressed this point, because before that we kind of never mentioned it. Users want to make voice calls, but in the extreme scenario we are considering, we think traditional voice calls are almost impossible. If you have completely fragmented networks and you have, you know, mules that hop by hop get the information from A to B. Yeah. So, but again, I think that the text improves the document because, of course, before we didn't really mention it at all. It was, I think it was just in our head that this is not an option in the scenario. And now we wrote some text why and explain. By the way, Aqua, I mean, if you don't feel that we addressed your comments well, yeah, maybe will you come to the mic and
yeah, I'm sorry I didn't reply on the mailing list, but I had reviewed your the updated draft and your comments and your reply, and actually I agree with everything. So I should have said that at the beginning. I'm sorry.
All right. No,
Thank
thank
you.
you very much. I mean, obviously, if other people have read the comments, yeah, Dirk.
Yeah, sorry, Dirk. Quick comment there. Shouldn't it be one of the advantages of ICN to have the choice? I mean, you can imagine to be even in fragmented situations where you happen to be in proximity of real-time communication.
Good point. Yeah.
And obviously, you probably would like real-time communication to happen in that case. But if I am fragmented, indeed, you actually automatically switch to leaving a voice message.
Right.
Right. So the
Maybe I should add some more text. You're actually right. I mean, there are certain cases where I can actually do voice, and I mean, I think we wrote it there explicitly. You can do voice over ICN if you want, but in most of the scenarios, the interesting cases we are considering is where it's not possible. But there may be, you know.
I think the point of ICN is the availability of content is the strong point of ICN, and therefore the availability of content in that case is the reachability of the end user. Right.
No, you're right. Maybe I should revise that text a little bit, just saying, yeah, if you have somebody in your proximity, of course, if you have direct connectivity, of course, you can do voice over ICN, and there have been some research papers on that. Yeah.
Good. Thanks.
Yeah, this was just a small comment. I mean, we talked about ICN data mutes a lot in the document, and actually we listed in this section, actually we gave a lot of pointers to existing work, and your comment, Aqua, was, well, has there been also work on ICN data mutes? And of course there has, so we just cited one of the papers. Yeah, and that's a good question. So I think your comments is that the old document sounded like all problems have been solved, which is certainly not the case. So we revised the text saying, well, yeah, so this is a kind of like a position paper. There has been a lot of work. We think ICN is a very good starting point to address all of these problems, but certainly there is need for further research, and I think it's now explicit in the document, right? It says like, however, further more detailed challenges exist, so that's important. And this one actually is a good point, and I would like to also mention this to the research group. So the comment was, how does this all relate to IETF standardization? And obviously it relates a lot to IETF standardization, because to make all of this feasible in an interoperable way, we're talking about mobile networks here a lot, you would need a standardized ICN protocol. And in that respect, the Icnrg is working, we're talking about this today, right? The adoption of the core documents, right? CCNX. I know, but so we're talking about this all the time. That's what I'm saying. Yeah. So in that sense, there is a big relation to standardization work. In order to make this vision that we kind of have here, I mean, there's been a lot of research, but in order to make this really deployed stuff, you would, in an interoperable way between different vendor devices, you would need a core protocol. So this is actually a good motivator that we need this kind of stuff. Yeah, so next step, I actually didn't change the slide from the last time I presented, because we think it's quite mature. But Aqua, really, thank you for your comments. I think it really improved the document, because a lot of this stuff was implicitly in our head, but we really didn't mention it, and you caught some good things there. Yeah, I'm open for suggestions how to move this forward. I think so. We, the authors, think it's quite mature at this point, the document. And I just wanted to highlight that the objective is an informational RFC, and we don't want to be this an exhaustive document, but rather like a position paper, right? So the question for me to judge if this document is ready is, if you read it, you should think to yourself, does it provide enough convincing arguments, and not, is it a complete list of all the papers out there and everything? So.
Right. So the chairs are actually inclined to last call this pretty soon. So I think this has been around for some time. You have received comments, they are incorporated. Okay, sound like today you got one additional thing you might want to do.
Sure.
So that could be the last thing you do in your revision, and then we move.
Okay.
We could last call this one, and that would be a last call comment.
Right. So just as a procedural question, when you do a last call, you want another extensive review from the working group, or you think this has been I mean, I don't care. I'm just asking as a procedural.
Yeah, we can do either way, but I think probably it's just, I mean, easier for you to go over this once again. Maybe could consider.
Yeah, I would consider Dirk's comment, maybe rewrite it a bit, and then we issue another version, and then we can take it from there on the mailing list. And see.
Exactly.
Yeah. Okay.
Okay. Just one kind of nit comment. I think you mentioned you use the acronym WG sometimes on your slide. So this is actually a research group.
Yeah. I'm
really
sorry.
pay a bit attention.
Do I do it?
I think so. Somewhere.
See here, it says specifically IRTF.
Yeah. Okay.
Yeah, maybe I should. Okay, I should check. Yeah,
So
it happens all the time. Like
we don't have working group items.
It's an
and so on,
RG
so
item. Yeah, of course.
All right. Thank you, Jan.
Okay.
So as you all know, the I in IoT stands for ICN. So we're now entering a block of IoT-related presentations, and I think Cenk is the first one. And here's the clicker. Yeah. It will be coming.
Okay. Okay, great. So, hi, my name is Cenk, and I'm from Hamburg, and we are presenting our, that's the first presentation of our publish subscribe deployment option for the NDN in constrained networks. So, if you look at, for example, at use cases or IoT scenarios where we have very low or resource constrained IoT devices, and especially content that is produced as a result of events. Let's take, for example, in this room, if the temperature rises to threshold, let's say 50 degrees, an event is triggered. And in certain scenarios, this event must propagate very quickly or immediately, actually, from one sensor to some sort of controlling unit that decides and raises alarm bells. So what the naive approach in the NDN is to do some sort of periodic polling so that the information can arrive timely to the controlling unit. But I think we can all agree that periodic polling in wireless based constrained IoT network consisting of hundreds of IoT devices may be, well, let's say infeasible, or it's very, I mean, they're waking sleepy nodes and they generate a lot of traffic, which is not what we want in the IoT. So what else do we have? I mean, in a request-driven paradigm, should we employ a push mechanism? Well, I think you all know that pushing in NDN is a very delicate topic. And if you scheme out this push mechanism wrongly, or if it fails, then you break the NDN beloved flow balance that we have, or you create cache poisoning scenarios, or even denial of service in these IoT networks. So we should stick to the NDN request response scheme for our approach. And this is what actually we propose. So we have a publish subscribe option that propagates the information that is generated by events in a timely fashion, or immediately actually, to some sort of control unit, or I'll say it, we call it a content proxy in this case. And the data is explicitly, data is not pushed. This is what I want to highlight here. So we deploy, or we employ a control plane in which we signal the name that is about to be that was triggered. And after receiving the signaling, which is just linked local, so it is just a name signaling to the next neighbor. And after receiving this, then the information is requested in a request-driven way. And this is then repeated hopwise in a hopwise fashion until the data is replicated to the content proxy. So I will go into this in detail. for our option, we are focusing on a certain topology, which is actually a sync tree that we built or that is rooted from on a content proxy. And there are working groups showing that actually a sync tree, or the role working group calls it DODEC, is actually very efficient in IoT scenarios because we have an M-to-1 communication where M sensors talk to, or the information from M sensors propagates to one source. So what we do is we build this sync tree by propagating prefixes, or prefix names on the control plane. And this is, like I said before, just a linked local communication. So this is broadcasted, and we call it PAM, the prefix advertisement message, and the PAM is broadcasted into the neighborhood. And once a neighbor receives this, it also joins the tree and repeats this process in a hopwise fashion until we have a fully tree. And it is important to say that all nodes in this network have only one fib entry, which is the default, which contains the default prefix and the incoming phase. So let's go to the publish. When information is generated or data needs to propagate to the content proxy, what we then do is we advertise this name. For example, here we have this the temperature at 10 a.m. that is generated, and we use NAM messages. We call them name advertisement messages. This is again just on the control plane and link scoped. So the NAM is received by the upstream neighbor. This is a unicast message. This is received by the upstream neighbor.
Can I ask a clarifying question?
Yes.
Because maybe other people didn't misunderstand this draft nearly as badly as I did.
Okay.
But in most of these other designs, the control plane is something that's running on top of the data plane, not in parallel to it. So you're defining something that is not running on top of the standard ICN data plane because it doesn't have the same semantics. So this is running directly on top of layer n-1 in parallel with the request response paradigm of the regular ICN data plane. Is that the correct understanding?
Yes. So what?
Okay. So I just suggest that maybe there are a lot of other people who would be confused when you call this a control plane.
Well, I think it depends. I mean, we can still run this on a let's say above layer 2, which is in parallel to, for example, like
the NAM message is not encapsulated inside an interest or data message.
No.
In which case, it is not classically a control plane running on top of an ICN data plane.
Well, I mean, if we have also scenarios like in the IP world with OSPF, where we have...
Which runs on top of IP.
Well,
all the OSPF messages are encapsulated in IP messages.
Yeah, but okay, but they use...
This message is not encapsulated in an ICN interest or data.
Yes, I mean, just yes, it is not an interest message, and it is not an ICN data message. It doesn't follow the interest data semantics. Well, that's probably a question of naming. I'm a bit confused that you say it's difficult to understand or to find this a control plane. I mean, maybe we can take it offline, but I would consider this a classical control plane. But anyway.
Yes. So the objective was to not overload the semantics of the interest packet, which requires a data in return. So we do this link local scoped signaling to the upstream router, which is in the fib from the first process. And after receiving this advertised name, then the information or the content is requested via content via interest and data. So what happens is that the information is replicated from the lower node in this picture from 3 to 1 by using the request-driven paradigm of NDN and CCN. And this process is then repeated. I mean,
I just had one question. So you said there's only one entry in the fib prefix?
Yes. So for this information, when we build the tree, there's just a default fib entry containing the upstream router.
Okay, so I'm looking at the consider where actually you have these devices and they are generating, because there's a typical, you have to onboard them and you give names
Yes.
under which they publish content and all. And they might have different names. So in that case, if the aggregator really wants to reach one of those devices and pull content out of it, then you're going to end up with the order of number of the embedded nodes in the constrained domain.
I guess Sheng said it a bit misleading. You have one FIP entry per prefix, or per a prefix aggregation point, which is a content proxy. So if you actually have different namespaces, then you have different entries in the FIP. But the point here is all names that have the common prefix aggregate, clearly aggregate to this content proxy. So you have per prefix only one entry in the FIP.
Yeah,
and that is then a sort of a prefix-specific default route.
So I think this point will clearer in the next slides. So
Okay,
I
I
will.
have one presentation on that. We can discuss that.
Okay, great. So what then happens? We propagate the data hopwise. I mean, we just repeat it iteratively until the content is received at the content proxy. So now the content proxy is contains the information that was published. And now the beauty of this is if another node wants to ask for this information or subscribes to this particular name, in the normal NDN world, the PID entries will leave the breadcrumb back to this node. Due to the default prefix routing that we have, the subscribe or this is a normal interest message which moves along the gradient towards the content proxy. There is no other way to go. So the content proxy will receive this interest, and if the publish or if the information that is asked is not there yet, I mean, it will stay open until the interest times out. So if the publish or the replication is received by the content proxy, the beauty is that the NDN forwarding will just immediately answer this interest. And of course, here no FIP entries needed because this is in the PID, right?
So I'm talking about if the aggregator wants to pull content from any of those the constraint nodes, and you basically identify them as different node IDs.
Yeah, but this is like Thomas said. This is a different namespacing. So we use in this prefix name that we use, content is not to be pulled from content proxy. Of course, you can run something in parallel where you have different FIP entries and different naming schemes for names that must be pulled by the content proxy. But polling is not something that we want to do here.
Okay, I'm missing something here, but okay. Anyways, thanks.
Quick question. Why did you discard the idea of just doing an interest data exchange?
Why we did this?
Why did you discard the idea that's been around for a long time of just doing an interest data exchange?
Well, the interest data exchange, I mean, okay, the interest.
In other words, the publisher sends an interest towards the namespace that the CP knows about, and when it gets it, that interest contains the name of the thing the CP should go issue an interest for down to the publisher.
Yeah.
The first interest is thrown away, right? And then the one comes back the other way. It seems like your hop-by-hop protocol basically reintroduces all of the push problems. They're just localized.
Well,
they're just localized on this edge part of the network, right? A bad sensor can still flood the network.
Can it? I mean, actually, you can.
Please go to the mic.
You can always flood the wireless. I mean, the point is this is only on the local link.
No, I understand, but I mean, for example, what if node 1 gets flooded with lots of these over each of its links?
Yeah, but then this is localized. I mean, this is.
So now you need congestion control on these published messages.
But that's the same with interest. I mean.
Yeah. But we already have to build DOS protection and congestion control for interest messages. Now we have to build another mechanism to do the same thing for this hop-by-hop scheme.
Okay, so you propose that this nums and pams that we introduced on the lower layer should be interest data mechanisms. I mean, so, but it's still generating a little bit more traffic than this approach. But I think this is a good discussion that we can keep further on. So the beauty of this approach is once we have this hopwise replication, and in a wireless network or in constrained networks, in wireless media, we have, of course, lossy links, so information can go, can be lost. So the thing is that we have, with this approach, publisher mobility. So once, because it's a hopwise replication, once the node detects that this information is not replicated because there was no interest requesting for this data, we can just reposition the tree or degrade into another position and take this, enter a new FIP entry into the FIP, and try the publishing again. So this is the beauty of this approach. And another beauty of this approach, because of this hopwise replication, is that we have a DTN-like characteristic here. For example, if we have a network that is partitioned, like you can see in the right part of this picture, if the link between node 2 and node 1 is broken, there is information that is published from the below nodes. It is stored, or these publishings are stored in node 2. And once the link becomes available, the publishments can still propagate to the content proxy. Are there questions regarding this? I mean, I think this is a really nice feature here.
So just to clarify, I thought the publish was a control plane action, but the publish is actually you're pushing data, right?
We are not pushing data. This is we signal names on the so-called control plane, and in response of this, of receiving this kind of signaling, we request the name. Well, it's still up to the router, of course, if it wants to request the name. But in this approach, it requests the name immediately.
So basically, it's still a kind of a trigger. What Dave was talking about.
I mean, we are in the name-based forwarding and proposing names. This is what routing protocols do in NDN.
Okay, no, I'm just confused on the publish action, but
it is probably easier than I mean. What you do is you tell that there is an entity which you use, a name entity, which you usually would do in a routing protocol. So that's why we call it a control plane message, but you do this only link locally. So you're not in the situation that you can DDoS any node in the network. You can only tell your neighbor. And and we had this discussion a little bit with Dave already, since you always can flood a wireless link, this actually doesn't introduce any new attack vector on the network layer, because you're not getting beyond the next hop. And you get these things which what Schenk just explained, the mobility and the partition tolerance, which you don't have if you actually signal path over the network. That's basically the point.
Okay, I think people have made their different views clear on these things, so please continue.
Okay, so to wrap it up, we propose, deployment option, public deployment option, which replicates data hop by hop. It decouples not just in time and space, it also decouples in synchronicity. This means information, or the authority of information, is given up to the content proxy. If information is asked by any entity, the content proxy will be asked first, or will be asked because the FIPS point to the content proxy. So this means that nodes can sleep after publishing their information. They don't have to wake up for every interest that is made. And of course, I showed you the producer mobility and DTN-like characteristic or the stability or resilience in partition networks. And of course, we have a minimal FIP state here. We did some experimental evaluation using Riot, the operating system for the IoT, and using CCN Lite, which is a lightweight implementation of different dialects, including NDN. So we used NDN on Riot, and this in a large-scale testbed, the IoT Lab testbed, with up to over 300s of nodes, IoT nodes in constrained environment. And it looks quite promising. I don't have the results here with me, but I can share them on the list or on the next presentation of this. then received, thanks to Dave, a lot of comments some weeks ago to the 0 version of this draft. And I think, Dave, you mentioned that the question of push versus pull is not very specified in the draft, and you're right, so it's not very specified. So we are updating this, providing a major draft update soon containing this.
So one more question on the producer mobility thing. So you're not talking about, so basically those nodes are not having global names, right? They're just having local names. So basically I'm monitoring a truck fleet, and basically the truck, I have to get sensor data from the truck. So basically you probably would give a global name to the truck. So because mobility cannot, if you're bringing actual infrastructure into the picture, there are different ways you have to handle mobility. So I see your mobility is somewhere limited to the local space.
The mobility is in this network, right? So if you look at this network, this IoT network, and mobility in our routing topology that we built, I'm just talking about the mobility in this routing topology.
Yeah, but what I'm saying is that CP, that's a localized constrained network. That's not really a moving network as in you would do for any IoT system.
I mean, if this whole network moves, it's still stationary in this sense, right? Like relatively.
So then the mobility will be to track the CP. You have to route all your names from the CP, and then you have to do some other producer mobility for under the CP name.
Yes, so, I mean, the idea is that
so that's the CP, not, I mean, that's a different problem.
Yeah.
I mean, you can view the CP or this type of topology as a typical IoT topology where you have a gateway or border router. Yes. And if you move the gateway or the border router, you move the whole network, then of course you need to apply appropriate.
Yeah, that's what I meant. Yeah. So when you say data, you should be careful. I mean, you're talking about within the constraint topology.
Okay, thanks. So to move on, there was another question from Dave talking about whether the content proxy is a repo or a cache, and the content proxy is a cache with guarantee, or it's guaranteed cache with lifetimes for the published content. So there was another long question from Dave regarding whether our proposal is like NLSR or chronosync, and I mean explicitly we are making distance vector routing and not link set routing, so this is quite different. And it's a similar approach to what is done on the Wall working group Ripple with the Ripple protocol. And another long question was, I mean, this was pointing into the question that we had before. Yes, we can discuss later. Yeah. So the draft status is it's still in the early state. There are missing parts in the draft, and we need to work on this. And we have to work out the packet header things, whether we go on this layer or using the intrust data approach. And the subscriber needs a little bit more elaboration. So we will provide a major version soonish, rather, at the end of this week, hopefully.
Yeah. Thank you. I think we had a very interesting discussion here, and I think it would be very good if you could continue this discussion on the mailing list, people, so you get some kind of conclusion of that discussion before we do the next version of the draft. I think that would be very useful.
Okay, thanks.
Okay, thank you. Can I?
Sorry, I lost time.
No, so yeah, Rob. Yeah, so I want to say that the good thing is that we have had a very interesting discussions here today. The bad thing is that we're doing pretty bad on timing, Ravi. You have, but the good thing is that it's your free drafts. I don't know. My proposal is that you focus on the notification draft, and the other IoT drafts we have had discussions on many times, so we can continue that discussion on the mailing list, maybe.
Yeah, try at least covering 2 drafts because
okay, but we start with the notification.
Yeah, right? Sure, yeah, because that's a good follow-up for this discussion.
So I should get that one up.
Hi. So this draft initially was in collaboration with Park, and that's a major change. So because they have moved to some other projects, so But this draft actually, we presented this probably, let me see, okay, 95, and since then there was this COPS paper, and where people were thinking about similar ideas. So we have some of the collaborators from that space also here. So this draft primarily talks about having this a new semantic of push in ICN, in CCN India networks. So I mean, there's been also some related paper in the last year SIGCOMM. I mean, I point this paper out because just to bring the point that just because you can do some flow control at the endpoints and flow balancing doesn't mean you have congestion control. So that's what the lot of the motivation of this paper points to. And particularly they consider the case where you're actually multicasting from a single producer to multiple receivers, and you have heterogeneous receivers with different end-to-end link bandwidth. And if you really want fairness, and even if you have network caches in the network, the slower ones actually drift apart from the faster ones, and then those caches are useless, and you're retransmitting the content and congesting the links. So you need more machinery. Just because flow balance is there, that's a good framework to have, but more machinery is required to actually, even with a simple interest data model, to actually get, you want to use the network fairly among different flows, and to ensure that you have end-to-end application rate that does in such a way that it doesn't slow down the producer a lot to the slowest producer, slowest receiver, and so on and so forth. So, so in that sense, I mean, so since then, in the last presentation we made, the comments from the chairs was to say, why these interest data abstractions fail, and that's what we tried to address in this particular revision. So, so yeah, so I mean, even of course in the last revision we had, we included a lot of discussion around flow and congestion control, and some of the work, this said work and all that fundamentally says that those can be applied to actually, you can leverage them to control notifications in the network. So this is the outline of the draft. I'll mostly stick to the main kind of discussion points where probably you can also provide a feedback. But this is the main motivation here, to say that, you have IoT, most of the data is going upstream compared to other normally smart devices. And I think the main motivation comes from applications like the URLLC application that you have in 5G. So these class of applications require very low latency. You're expecting some, because you're talking about this vehicle-to-vehicle autonomous driving kind of situations, and 1 to 10 millisecond, and absolutely kind of zero kind of packet losses and stuff. And of course, you have an entire industry that fundamentally depends upon pub subsystems. And even IoT systems, most of the things like MQTT, they're all based on this kind of application. Fundamentally, that's the fact that the messages themselves, data itself is produced at random intervals. And so the only thing you can do is, I mean, the efficient way you do is to basically notify the users when it is produced. Yeah, so, and also you have, I mean, there are some other proposals or the ICN protocols that fundamentally support both push and pull. So I just wanted to say, I mean, this probably could be something that might be demanded out of ICN protocol too. So the main thing here is, I mean, so some of the requirements we listed here is that you have to support the push intent. So when you're actually pushing out the data, it has to reach the set of receivers that it's intended to support multicast security. I mean, you should be able to get all the security features that you have in a normal named data object. Routing and forwarding support, in the sense that you should treat it separately from pull, where you can actually do different forwarding strategy mechanisms to and basically learn from where the data is coming from and stuff. So here you may not have any response. You're just pushing data because data users just subscribed once and you want to push it out. And you want to minimize processing, should be subjected to minimal PIT and CS processing. You avoid this involving them in the message processing pipeline. To basically, it is again to ensure it's meeting the need for what you want to do with that thing is to push it out. So there are 4 basic approaches that we define in this draft. And as I said, the main changes has been in this section of using interest data abstraction for push. So you have long-lived interest, you have polling that Shenk was talking about, you have overloading interest and interest triggers that Dave was talking about. And so most of the discussion that we provided in this draft is in the context of a normal infrastructure where you have multiple providers and there are multiple consumers, and they are all operating under the given group prefix. So, I mean, the consumers don't know who is producing that piece of data, but the key is that the consumers want to sync up with the producers that is generating data in this random manner. So the basic thing is, given that and you have interest data abstraction, what are the different ways you can achieve it? And that's what we discussed that in the draft. So basic assumption here is that we say, okay, there's a long-lived interest. So in the long-lived interest, you're fundamentally assuming that, with the interest data model, and you're saying that, okay, they have this, you have this n number of providers producing data, and the producers themselves are not in sync with one another. You basically, I mean, the consumers can ask data based on the fact that they are being generated in a sequential manner. So the only way you can actually get the data, because you don't know which content ID is being provided by which producer, is to actually kind of multicast this interest out to all the providers out there. So there are inefficiencies with this solution. Is that as I said, that fundamentally you have to send out all this interest. It increases the fundamental bit state, and the main important thing is that because data is only coming from one of the providers, you have a lot of redundant bit states lying in the network that may not be consumed. And the other thing is that how do producers themselves sync among themselves, right? So that's another syncing problem or another notification problem. So unless you solve the first problem, you cannot really solve the second problem, right? I mean, if you're doing this in the push model, all you do is that group IDs, I mean, the names can be purely mutable based on either content hashes or something, and you would push that content out into the network. So this is with the long-lived interest. So the way you address this is that, okay, you, instead of having this long-lived interest and having this state in the pit, you can do it by polling, right? So what Shenk mentioned was you poll the network. So here polling would fundamentally mean by saying that, okay, you have this set of providers, and fundamentally they are.
Ravi,
yes.
Just for your information, we're running out of time. We only have 2.5 minutes left of the meeting.
Really?
Yes.
It's half an hour more, right?
Until 12. Oh, sorry. Then we're okay.
So that's.
Don't worry.
I was thinking I got 45 minutes, so somewhere close to that. Anyway. Okay, so the way you avoid this thing that, okay, you don't want to send all the interest to all the operators is by saying that you are publishing them under different timestamps, assuming that these providers can be synced in time. And then you basically querying based on some exclusion mechanism, give me something that is after this time, and some using some certain logic, some kind of logic of that kind. But the basic problem with this approach is that it leads to message losses, because the consumers definitely don't know exactly at what instances because they are fundamentally split, they're separated in time and space, so they don't know exactly at what instances they are basically the content has been generated, and there's a good chance that you might lead to message losses in this scheme. So the other thing is you can avoid that problem by saying that, okay, I'm not going to have these producers sync with each other, but I'm going to give different namespace for each one of these producers. And now you basically give a provider ID as one of those one of the name components, and they start publishing under that name. So your query would be straightforward, but the key thing here is that now the solution becomes more like a host-centric thing, because the consumers have to know all the producers out there. It avoids all the packet losses fundamentally, because you can kind of pipeline this interest and you can get all the data, but it still doesn't solve the problem of having this pit state because of long-lived interest. And the other problem is that if you say that the group ID itself is shared among multiple devices, it goes back to the problem of having long-lived interest, where these devices under the group have to now sync somehow to make sure that the names themselves are basically there's no they are not using the same names to produce content. So the way you could avoid this is again going back. Okay, you are giving this provider IDs and group IDs to different providers, but now you start producing them under different timestamps, and the query would be to basically give. So here, basically, you are doing things mostly at the some kind of an application level. You're sending out interest with a certain norms, and basically give content after a given amount of time. So in this particular case, you are now at the application layer, you're aggregating bunch of interests, and then you're responding to the consumer's request. So again, this inefficiency with polling. There's more load on the providers here because fundamentally the uses of caches becomes irrelevant here. Consumers, again, here the other issue is that you have to know all the potential providers. So this other thing on basically saying that now I could have, instead of saying that producers need to know all the providers, I will have one, say some proxy server. The producers themselves will publish to the server, and then I just know the server and get the content from it. But again, this server will offer some kind of aggregated response, but then this goes into the same IP model where the server becomes a single point of failure. Again, the caches are not useful as in the previous case, and it kind of boils down to a host-centric approach. Again, so this is the other thing about interest overloading. So in saying that with interest overloading, what you're saying is that I would put the payload into my interest messages and send it out. So this fundamental issue here is that now the routing and forwarding has to fundamentally differentiate between the where you're actually pulling content, where we are actually pushing out. Consumer, again, somewhere, this again, because these are pushes, the fibs are somehow coming from the endpoints, and that should fundamentally reach all the providers. So that's where the routing implication comes from. Again, the issue is that you're always engineering the network for certain size of interest. Now, it violates that principle because you can't go beyond a certain size of payload. So the other way you can handle this is using the interest trigger mechanism. Is where basically say that you trigger by basically giving an indication that okay, there is a new content to be fetched, and the consumer fetches it from the endpoint. But the thing is that it at least consumes one RTT delay. So I mean, it fundamentally affects things like mission critical applications. Again, triggers have to reach all the receiver endpoints, so you still have the routing and forwarding challenges. And the trigger namespace, so the trigger namespace have to be carefully defined, carefully designed here. So other parts of the draft we have not changed here. The things on protocol semantics, flow congestion control discussion, and there's one use case we show how you could use notifications for pub sub. So those fundamental things have not been touched. So questions here and any comments on this draft? So shall I just move on to the next draft?
What is your plan with this draft?
I mean, I would definitely like to see this somewhere because as I said, like the flow balancing by itself just gives you a first step, but you need some other mechanisms to handle congestion control. That's what the paper actually indicates. But as I said, you definitely need some other mechanism. If you have notifications, you have to, but some of the mechanisms that the set papers designs where they actually are sending that window information from the consumers into the network to control the data that's flowing down or to get the best application rates to the receivers. Those things can be easily applied in this case too. So I mean, this is what I want to understand is, I mean, because this becomes a very important point. I mean, we cannot just say that, you can do chronosync because chronosync is there, but again, that's another protocol that is running. You have to exchange the registries, you're pulling content. They don't solve the case of where you require this mission critical updates and notifications and stuff. And to say that, no, we should be practical in the sense that considering IoT and the social networks out there, people who are actually building the systems would be happy with just having this one abstractions to support all the applications. So for me, from my perspective, application requirements come first. Of course, then you have to engineer the network to make sure that the security and the congestion control mechanisms are taken care of. But this abstraction seems to be pretty important to me. Push.
Thomas from Hamburg. I pretty much agree with most of what you said in the presentation, but it doesn't really, it doesn't really seem to fit to the title of your draft. I mean, I would consider the title of your draft would be better, something like problem statement and brief survey or something.
Okay, because the thing is that we talked to Park and we discussed this notification, and so it was actually proposed as a kind of extension to the CCNX protocol. But then the thing literally then it took, I think, more a research direction where we added the flow congestion control. Yeah, definitely I can change that to put it as research directions as Jan had in his draft to make it a broader scope and stuff. But I think definitely there's this good community that is looking into this problem and suggesting different ways. Even in the paper in that RCP, they fundamentally break away from the normal interest data mechanisms to actually push the window mechanisms and stuff. I think that's a very good paper to read and say that just because you have caches and flow balances, there's no guarantee there. So
okay. I think most of us would agree that, say, asynchronous notification and push, that's one of the interesting and crucial topics for ICN, and there are really different approaches. So you mentioned data set segmentation, interest, all these things. I think it would be good to kind of, keep working on this document, and maybe so people are still working in this field. So I think that this could for some time be like a living document, perhaps.
Sure. I'll keep it because it's an important thing, and I'll at least definitely. I haven't read Schwenk's drafts, but I will definitely read that and probably provide pointers and probably see if that is one of the schemes you could adapt as in part of the interest data abstraction model. So,
all right, thanks.
Okay, so which one do you want to do next?
We can do the IoT design considerations.
Or yeah.
That seems to.
We heard that more times than the architecture.
Oh, okay, we can do the architecture because I think that's closed for some adoption and stuff. So I thought, why not? Because Dave gave a lot of comments there. So yeah, we can do the architecture one. So. Okay. Hold on. Okay, so this is like more the kind of you can say a complementary draft to the design considerations draft, because when you do IoT implementations, you have to invariably depend on certain toolkits like middleware functions to onboard the devices, and then basically authenticate it to the network, and network authenticates the device, do your device discovery, service discovery, content distribution, and so on and so forth. So this is fundamentally kind of spending a lot of the time in to basically give people a motivation on solutions that can be around to serve those kind of functions, and basically we also provide a lot of discussion around how ND and CCN are mobility first. There are these two protocols we consider and specific discussions related to that. So again, we have collaborators here. I mean, folks who are in IoT space, and we have folks who are doing kind of more something that involves name resolution system, and we have people who work from the NDN space too. So both those opinions and kind of solutions that are being pursued are being reflected in this draft. So the main change from I mean, a lot of changes are basically spread around the draft, but we kind of in the section 4.1 we kind of separate. We had only initially device discovery, but we added one section on device onboarding and discovery because they are fundamentally two different things. So when you do something like onboarding of devices, it's to basically you want to it's more about authenticating the device that is coming into the network, and the network or the device authenticates to the network, and network also authenticates to the device. So that's the onboarding one. And the discovery is when you're actually announcing to the network somewhere that, okay, this device is there, and so you can route to this device, you can pull content from this device. So that's where my question for Schenk was. In most of the discussions we have in the device onboarding, you actually give a name to the device, right? So you actually say this is a thermostat, or basically those names could also be actually coming from the actual aggregator point itself. So, but the sizes, I mean, if you want to get data from that, it's actually operating on different namespaces, and you also have some trust mechanisms that is actually rooted on that namespace. So that's where my question was earlier. So anyway, so this is mostly the outline of the draft. There's a lot of material in this draft. I mean, it's good if some people could comment and basically tell us, how we could improve it. But I'll just go through the updates of this draft. So we presented this in '96 IETF, and then we haven't received any feedback yet, but we did a revision of it considering ICN IoT. There's a lot of work going on for the last 3-4 years, and some of it is reflected in this. So as I said, this is a design consideration. This is kind of a follow-up from the design consideration stuff. We basically consider a typical IoT system architecture, ICN-based middleware functions. So we discussed the middleware functions to achieve secure self-configuration and scalability to accommodate many IoT devices. Again, we provide high-level solutions as well as kind of specific mechanisms that you can do in NDN, CCN, and also from the mobility first perspective. For specific middleware protocol solutions, these are also discussed in the draft. So one of the things that we changed in this ICN IoT system architecture is we added the authentication manager, because that is a very important component when you're talking about onboarding devices. I mean, but it's still a kind of a function, a service function. It can be kind of integrated with the IoT server or the basically to the, sorry, not IoT server, but with the local service gateway within the domain too. Again, this is assumption that architecture, yes.
This would be Thomas from Hamburg. A question: I'm a bit new to this picture, maybe my fault, but can you relate these entities to the typical, let's say, 6-LoWPAN architectures?
Yeah, sure. Yeah. So it's very similar. I mean, you have embedded systems that they can, if you want, they can mesh, or they can also form a tree to the aggregator. It's very similar to what the earlier presentation was. And then you have a local service gateway. The local service gateway is within the local domain boundary. And then pardon me? It's a border router kind of a thing, and then it basically interconnects to the service gateway. Sorry, it connects to the kind of the infrastructure, and then you have the authentication manager, which can be actually within the local domain or outside in the internet kind of thing. And then you have consumers and services that is asking for the content that is being generated, so that goes to the actual network infrastructure network and basically comes out. So the IoT server can be, so this is basically assuming that because in IoT you can do a lot of hierarchical processing, right? So I mean, data that is coming from the embedded system gets processed in the aggregator can publish it in the new space, and once it comes into the server, so data can actually come from the IoT server itself. So that's where we have large scale, like WAN level pub sub kind of systems flying. But you can also have data that is being consumed within the local domain, like the embedded systems that is connected to one aggregator might talk to another aggregator to get the data from its own embedded system or something. So you can have local domain communication, as well as you have infrastructure level communication. So it covers both the aspects here. Yes.
We have built a few toy systems to do IoT.
Yes.
They gave a short talk, I think, Monday evening. It's a Barbara or something. I think our experience show that naming actually is the fundamental.
Yes.
I didn't see that actually discussed in this.
Oh yeah. So basically, we have.
Where's your name architecture?
Yeah. So basically, we have the device onboarding and discovery. So at that particular point, you give a local ID. Then when you do a naming service, you can give a global ID.
That's talking about your namespace architecture. Where is in that outline?
Namespace architecture or
Right, the namespace structure. Where is that? You need
namespace? You're
you need-
naming, right? You're basically, you want to give a name to a producing endpoint. That's
It's not you give a name
yeah.
to this fellow.
Yeah, yeah.
But
no,
rather, what is your name structure?
Oh,
to
yeah, yeah.
the
So,
IoT system, and
Ye-
because that ties together the identity, the security.
yes, yeah. So
auto-configuration.
here we discuss, the draft discusses with respect to both the architectures, ND and CCN, as well as in Mobility First. Mobility First, we assume we are giving self-certified names.
But
In the
I'm
other case, we are
asking
giving
where that discussion.
Where is that?
I think what you're looking for is more what you can find in the design consideration document, where you talk about how to construct names, how to reflect timing and sequence numbers and
Not that. I'm
things.
asking about the namespace structure.
Yes.
I
So
do not see that in this draft. Maybe we can take it offline. But
Sure,
that's a
sure.
fundamental.
We have a lot of
case.
discussion on naming and
I'm
basically.
not talking about discussion. I'm asking for that graph showing how the name.
This one. This is simply a system architecture. I'm not showing I mean, I'm not specifically going into the protocol details or specific naming functions here. So, I mean, this is simply saying that this is what a typical IoT system looks like. I mean, irrespective of whether it is today's system or ICN system, they'll all have the similar setup. So that's all this is trying to say.
Let me just say one more thing. I think we need a much longer discussion. I don't want to waste people's time.
Yeah, sure,
here.
yeah, please.
But I want to say that when people talk about information centric,
Yes.
let's keep in mind, it's not just say we care about the information instead of location. The key point about carrying the information is how you name it. And that is the fundamental challenge.
Lisha,
I thought I'm done.
is there any chance that you could provide a presentation on what you mean with this at the next Icnrg meeting?
I would be happy to. Actually, I was thinking how many presentations I should do. I mean, I owe this group a lot that I haven't done.
Yeah.
The early discussions about the pull and the push, we're actually writing a paper on that.
Yeah.
Why pulling actually is an architecture decision. It's not an application per se.
It would be really helpful.
You can list me. I'm always working for deadlines.
Hello, Muhammad from Bournemouth University. I have a question regarding to IoTs, like how you are going to solve the addressing issue. Like in IoTs, you should have a global ID.
Yeah, so of course, yeah, you basically name it. So I mean, we talk in terms of naming, offering namespaces under which, I mean, so when you talk about IoT, we say that, okay, you could name devices, services, and content. Okay, so the thing about how you would locate that name to a particular location is the name resolution problem, right? And there are different ways to do it. So here mostly we focus on how do you assign names. I mean, when you talk about IP context, you are naming interfaces, right? And then applications also tend to use it. But in here, we are basically, there's a clear separation. ICN focuses on giving names to services, content, and devices, and then you can basically place it on any kind of transport.
Chair hat off. So this is personal comment. I think it's at least a year and possibly 3 years premature to try and construct a system architecture for ICN IoT.
Mm-hmm.
This top-down stuff, it presumes an awful lot of things are decided that are not. And we need a whole lot more bottom-up work on each of the individual pieces before we understand what kind of a system architecture we should have. If any, we may not need a system architecture, single system architecture.
I'm basically
for it. So that's just my personal view.
Yes.
I think this work is at least 2 years premature. It presumes that we know a whole lot of things about how the individual pieces work that we don't know.
Yes. So, I mean, because I looked at several of the architectures and we have Emmanuel
I
and
thought
folks,
I was done, but I want to strongly second what Dave said. I didn't put that strong word, but I think that is where the situation is. Build an IoT system yourself, then I think you can understand a lot better.
Yeah, okay. I mean, we do build IoT systems, and I mean, I don't know why there's so much of this with this system setup, because this is a very typical system setup in any IoT system. I mean, whether it's IP or ICN, I don't know why should this differ, because fundamentally all this is saying that you want to kind of decentralize your control and functions in different points to scale the IoT deployment.
Paper design is one thing. Build a real system.
You know,
and teach it
yeah,
what
we
that
build. We
is.
don't. It's not. I mean, we build it in the labs. You are welcome to.
You
come and see our-
actually, I heard you contract it out to the
No,
programmers.
we
to
do a
write
lot
it
of
for
building.
you.
I mean, you shouldn't talk for us. You should come to our lab and see what we build, right?
So Ravi, I think I think it's fair to say that this document at this point does not really say reflect experimentation insights, or like it's really not really based on. It doesn't. At least you don't make that connection really. I mean.
So, I mean, as I said, like we are mostly talking at architectural and basically some kind of protocol level designs. But the key thing is that, I mean, what we discuss, I mean, I don't have that picture, but there's a picture in the draft where we talk that, okay, there are basic functions that ICN provides in terms of caching or in-network computing. That's fundamentally ICN functions, but you have to build certain basic middleware functions like what we discuss in this draft to make IoT systems self-configurable, scale, and to do large-scale content distributions and stuff. So that is the focus of this draft. So, Emmanuel.
Yeah, Manuel Boccioli, I just had one more question on the.
Yes.
Yeah. So what are the aggregators?
So the aggregators are simply I mean, they are the unconstrained nodes to which all the sensors and embedded systems can talk to. I mean, they're probably called by different names. Probably the proxy, or it's basically like the Nest Hub or anything is the aggregator.
Some function of the gateway, is that it?
It's, I mean, I separate the gateway, which is basically at the border to the infrastructure, but this is like you have several aggregators to which all the embedded systems are talking to. So, I mean, you can do a lot more optimization there to ensure that battery lives and all things, that kind of things can be taken care of. So, yeah, basically you can say the DODAGs for the RPL will hang out of the aggregators, right?
May I add a question here? What do the arrows mean then? Because I mean, earlier you said the local service gateway would be something like a border router, and now you said the aggregators are from basically the unconstrained nodes that are like outside the.
Yeah. So aggregator, as I said, aggregator is like the I mean the route to which all the constraint nodes
Yeah,
talk
sure. But
to.
then I would expect that the embedded system is communicating to if the arrows are communicating to the aggregators via the local service gateway.
Yeah, aggregator would talk to the local service gateway. That becomes entry point to the local domain. So if you want to put any kind of policies on who is able to access the data.
My problem, I'm confused with your arrows.
Arrows, I mean, which arrow are you confused with?
Oh, I mean, I don't.
So it's an embedded system to embedded system is saying that you could have a possibility of not purely tree structure, but you could also have the embedded system talking to each other. So you could do a kind of a multi-hop communication to the aggregator. Aggregator to aggregator are basically saying that these are the nodes through which you would, I mean, that is a purely and the local domain, but not like the LLN connections, but good reliable links to which you connect to each other, through which you can do service discovery and so on and so forth to pull the content. So if aggregator wants to get the data from the embedded system, it can directly go from one aggregator to another aggregator to the embedded system, or you can go from the aggregator to aggregator and pull the content, because you are probably again publishing the content in the aggregator.
So now we are really running out of time.
Okay. Anyway, so this is like, as I said, like we have provided more discussion on device onboarding, and so there are a lot of kind of sub functions that we discuss under this, like device polling, mutual authentication, key generation, distribution, protected data transfer. We provide discussion in the context of NDN and MF. And the basic assumption here is that the embedded system is coming with a pre-shared key or could have a symmetric key to bootstrap the whole, it basically onboard the device into the system. So we talk about naming service. Device discovery gives you a local ID, but you can also give it a global name. And The names can either come from the preloaded keys, like for the self-certified keys, or you can offer names with the certificates from the authentication manager or the local service gateway to the device. So that fundamentally gives you ability to do global communication. We talk about service discovery. Discovery, I mean, there's a discovery between the embedded system and the aggregator, but there's again service discovery is between the aggregator points, and you want to do secure service discovery to ensure that you're only allowing legitimate users to do it. And there are discussions on that also. Context processing and storage. So this context processing fundamentally in CCN NDN, you have name networking function, name function networking. In mobility first, there's a compute layer. So fundamentally, it's about talking about how devices can expose certain context to the network layer, and then you can use the application level context to match with it, and to basically pull some service functions and to produce data in an appropriate manner that meets those context queries. Then we talk about pub/sub management. This goes into the previous discussion also, but being pull-based architecture doesn't actually support pub/sub. Then there are different ways to do it. We talk about co-ops, but we also talk in mobility first that where you can actually do some control plane at the service level, control plane and data plane segregation, where you authenticate.
Ravi, we can only spend one more minute on this. So
yeah, so I'm done here. So there's also some discussion. We talk about when you have multiple IoT islands with different naming structure, then there's a proposal on an inter-names kind of architectures to handle those kind of scenarios. So next steps, as I said, I'm sure there's a lot of comments, and Dave comment is premature work, but I think we will definitely keep this, we'll try improving this draft. I'll take these comments and probably look at some of the experimental work. We have been keeping track of what Indian IoT does and stuff, so it's not that we are doing this without considering that kind of work.
So let's just check who has read this draft, either the latest version that just came out recently or the previous, any version of this draft. So it's just a few hands. So if you think this is interesting work, please read the draft and comment on the mailing list and discuss it there. If you have other ideas of how the research group should address these issues, we're also glad to hear them, because I really think we need something in this area. If this is the right thing, or if there's better ways to do it, we should discuss, and any ideas and comments are most welcome.
Sure. Yeah, as I said, like, I mean, as Lisha was saying that, we don't have the bandwidth to do all kind of applications. We do build systems, but if there are, I mean, there is Jay who is doing. He's an Indian collaborator, so we have a lot of inputs from him. But if other Indian folks want to join in this draft, surely, yeah.
And unfortunately, we don't have time for the design considerations. But I just want to do show hands on that one also. Who has read the design IoT design consideration drafts? Any version of it? So that's still also just a few hands. So we need more eyes to look at this. We need what you think about it. If you don't think this is the right thing, we need other ideas how to move along. So please, if you think ICN and IoT is something that can be useful, we need to find a way to move forward on this.
Yeah, I mean, I spoke to the volunteers, so they are working on it to give us more feedback. So,
okay.
Just quickly, I had volunteered last time. I've now read it. I haven't sent you my comments, but I will on the other draft. But it seems like the comments about sort of an overarching IoT architecture are important comments. I almost wondered whether there's some other places within the broader IETF, IRTF, where there's IoT work going on that, there are architectures being discussed. There are things like smart object networking being discussed. There's security considerations being discussed, and there needs to be coordination there.
So, sorry, we just have 1 minute.
Yeah, of course. I think there was one of the comments to. Yeah, okay, sure. No problem. Yeah.
Thanks, Eve. Thanks, Ravi. So IoT and ICN, that's really an important topic, and we see this as a forum to facilitate more experiments. So if you are doing some work, please feel free to kind of tell people about it. It doesn't have to be written up in a 100-page draft or something, right? I mean, just a presentation about some experiments, maybe some principled idea. That's also really helpful. I mean, we don't need to, produce documents just because the IETF also does this. So we are really interested in just, having discussion and learning things. Okay, so with that, so we have a couple of things coming up. So there will be the ICN conference end of September in Berlin. And especially if you're interested in IoT, I recommend attending that. So there will be a Think2Think meeting on the weekend before. There will be a Riot Summit, so directly on the days before the conference. And we're also planning to have an Icnrg interim meeting after the conference. So we often use that to also bring new people to this group, and also maybe to have presentations about, for example, presented papers at the conference, but go into a bit more detail and have a bit more time for discussing technical aspects. So it's normally quite rewarding, these meetings. Yeah, please consider coming. We also plan to meet in Singapore, so definitely have another regular meeting during the week. The chairs would also be available and willing to go for a weekend Sunday meeting. Depends a little bit, of course, on contributions, what people think we should be discussing, and so on. But this is definitely an option doing that. Finally, there is an IEEE Communications Magazine issue coming up on ICN security. So if you're working in that field, deadline is November 1st. I think you can find the call for papers and everything online. With that, yeah, we are done. Thank you very much for coming. Thanks to all the presenters, and hope to see many of you in Berlin.
And most of all, thanks to Cedric for taking notes.
Yes.
Thank you. I watched the wiki. No. Okay. Okay. Thanks. Thanks, everybody. We're done.